You are welcome to Math Hub S. Today we are to continue on our lessons, sequence and series. And as you know, the previous lesson, we were able to establish the two types of sequence, which are arithmetic and then exponential sequence. So today we are going to look at arithmetic sequence, arithmetic progression, or linear sequence. The sequence 2, 4, 6, 8, 10 is a linear sequence because it has a common difference. We can see that the difference in between the terms are the same. We have 4 minus 2 to be 2. Then we have 6 minus 4, 6 minus 4 to be 2, 8 minus 6 to be 2, then 10 minus 8 to be 2. So basically the differences are the same, and we call that difference common difference. So any sequence at all that has common difference is what we call linear or arithmetic. When you have a linear sequence like this, the first term we call it U1, the second term we call it U2, the third term we call it U3, then U4, U5, in that order. So it continues in that particular way. Now until we get to whatever we want. Any term at all is called UN. UN standing for any term at all that you would like to find. For instance, if I want to find U100, then N becomes 100, so I'll get U100. And U100 is the 100th term. The 100th term of the sequence is called U100. So generally we represent any term at all by UN. If you want to find the next term of this particular sequence here, we have 2, 4, 6, 8, 10. The next sequence, we can use a formula to find the next sequence. That formula is given by UN is equal to A plus N minus 1D. This is the formula that we can use to find the next term of the sequence. The A represents first term, so where A is equal to first term is equal to U1, which is the same as first term. We call that first term. And RD and D equal to common difference. Common difference. So that means that if I know the value of A and I know the value of D, then I can find any term at all that I want to. So for instance, we have here 2, 4, 6, 8, 10. If I want to find the next term is U6. That is the safe term because we have U1 first term, second term is 4, third term is 6, fourth term is 8, fifth term is 10. So the safe term is U6. That is U6, which we are going to find. Now you can see from here that here is 5 for U5. That is the fifth term. The 4 represents fourth term. It's talking about fourth term. Then we have 3. So that means that safe term is going to be written as U6. That is the safe term. And that 6 is the N here. So U6 is equal to our A, because here we have A. Now our A is 2, so we have 2. Then plus N minus 1. N is the number here. So N is 6, right? So 6 minus 1 is going to be 5. So we have 5. Then D. D is the difference in between the numbers. So we can take U2 minus U1. And if we take U2 minus U1, we are going to get 2. So we write here 2. You can also take U3 minus U2. That will be 6 minus 4, and you are getting 2, or 8 minus 6, or 10 minus 8. In either case, you are getting 2. So you see that here we are coming out with 2, then 5 times 2 is 10, and finally we are coming out with 12. That means that the next term in the sequence is 12, right? and we can see that by observation. We have 2, 4, 6, 8, 10, and we have 12. So then we have 14 continuous in that order. So basically this is the formula. This is the formula that we use to find any term that we want. If we want to find the 100th term, we can do that. The 100th term. The 100th term is if we start counting from here 1, 2, 3, 4, 5. The one that will come at the 100th position is what we call the 100th term. So that term, the value of the 100th term is given by, and we know that our formula for any term is un is equal to a plus n minus 1 d. So u 100 is the 100th term, u100, and that is equal to a is 2. That is the first term in our sequence here, that is 2 here. Then plus n is the 100, so 100 minus 1 is 99, so we have 99. Then d, and d is 2, so we have 2 here. And we are getting here 200 is equal to 2 plus 99 times 2 is 198. Therefore plus 2 is giving us 200. And basically u100, which is the 100th term, is 200. If we start counting u1, u2, u3, then 200 is the 100th term. By the time we get to 100, we have obtained 200 to be our answer. That's what we are seeing here. So this is the formula, as we said, for finding any term at all that you want to find. Now we are going to look at how this formula has been obtained, and we are going to do that using the sequence here, or we can use any other sequence at all to obtain our formula. So right away, let's zoom into that. We are saying that if I have a linear sequence, let's say 5, 10, 15, 20, this is a linear sequence because we have a common difference. 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15, 2 is 5. So there is a common difference. Once there is a common difference, we can call it a linear sequence. We can also have a different linear sequence, for instance 2, 4, 6, 8. I'll be using this particular one. Then 10. This is also a linear sequence because the difference between the numbers is the same. 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, that order. Now you see that there are 3 dots here. There is 3 dots here. You can see that 3 dots here. These 3 dots means that it continues indefinitely. And if you come to this side, you see we have those 3 dots here as well. Also means that the sequence here continues indefinitely. Continuous simply means that there are many other terms which still follow. So if you want to find any term of those remaining terms, or any term at all, that term can be found by using the formula un is equal to a plus n minus 1 d. As we have established in the first case, we have already used this one to solve some few examples. So we are going to deduce how to come out with this formula. If we look at the sequence here, 2, 4, 6, 8, 10, the first sequence, we call that one u1. The second one, we call it u2. The third term, we call it u3. That's the first term, we call it u1. The second term, u2. The third term, u3. Fourth term is u4. fifth term is u5, and it also continues like that. So from here, our u1 is equal to 2, our u2 is equal to 4, and the 4, how did we obtain the 4? We can see that it is an addition of 2. We added 2 to the first term, which is 2. Therefore, the 4 is written as the first term, which is 2 plus 2. And this second 2 here is the difference. Now the third term is u3, and u3 is 6. How did we obtain the 6? The 6 has been obtained by just adding 2 again to the second term. So we have 2 plus 2, 4. This is the second term. Then we added another 2 to the second term, and we had a 6. Now the fourth term is u4, and u4 is 8. That one too has been obtained by adding 2 again to the third term. That is adding 2 to 6. So we have 2 first term. Then we added 2, we had the second term. We added 2, we had the third term, which is 6. So the fourth term, we add another 2, which is the 8. And then the fifth term, u5, is 10. Then the 10 has been obtained by adding 2 to the fourth term. So this is the fourth term, 8. Then we added plus 2. So from here, we have used a sequence here to obtain these numbers. So which means that if I use the sequence at this place, I'm going to get different numbers, because the common difference here is 5, and the first term is also 5. So if I use that place, I'm going to get different numbers. And because we have so many linear sequences, each of them with a different first term and then a common difference, we are going to represent the first term and then the common difference by variables, so that the variables will stand in for any linear sequence at all that we are going to talk about. Right. So here I'm going to say that let A equal to the first term. So we are going to replace our first term by A, and D equal to the common difference. That implies that I'm going to represent the 2 by A, because we are saying that let A equal to the first term, and we know that the 2 here is the first term, and if we come to this case, this 5 is the first term, and this case 2 is the first term. Therefore, I'm going to represent this first term, the u1, by A, so that the A will stand in for any sequence at all, not just those that I've written here, but any other sequence that we want to use. The A will stand in for that sequence, the first term for that sequence. So we are going to get A. Now here is going to be A, that is this 2 here, that is the first term. Now the second term is 4, and the 4 is we added 2 to the first term. So this A is the first term, this 2 is the first term, this 2 is the first term, this 2 is the first term, and this 2 is the first term. So basically we added 2 to this 2 to the first term, which is this 2. So now this A is going to be A. Now note that this 2 is the difference between 2 and 4, 6 and 4, 8 and 4, which is the common difference. So I will say A plus D. Now this one, we added 2 of the common difference. We added the difference 2 to obtain 4, then we added another one 2 to obtain 6. So that means that we added 2 of the common differences. So that will be A plus 2D. Then this place, this is the first term, which is 2, and then we added 3 of the common differences, which is a plus 3d. Then here, this is our first term. Then we added 4 of the common differences, and that is a plus 4d. A plus 4d. So if we rewrite them, we have here u1 is equal to a, then we have u2 is equal to a plus d, then we have u3 is equal to a plus 2d, then we have u4 is equal to a plus 3d, then we have u5 equal to a plus 4d. So basically you can see there is a pattern at the right side. We started with a, then the second one is a plus d, then the third one is a plus 2d, then the fourth one is a plus 3d, fifth one is a plus 4d. So you see that at the d side we are basically counting 1, 2, 3. So this place where there is no d is 0d. So we have 0d at where there is no d. Then we have 1d, we have 2d's, we have 3d's, we have 4d's. So basically, and here is counting. So when we have u5, then we have 4d. When we have u4, then we have 3d. When we have u3, then we have 2d. So that means that if we have u6, I'm going to get a plus 5d, because here is 5, then here is 4. So if I have this place to be 6, then I'm going to get here to be 5. So that will be 5d. So let's try to make a conclusion. So that now means that this side, you see we have u4, u5, u6 going. We are now going to write it generally. Instead of writing u6 or u a number, we are going to represent the numbers or the number by a variable n, so that anytime we can replace the variable with the number that we want. So un is equal to, A is for any first term of any of the linear sequences. So that will be a plus, and note that here is n, a plus n minus 1 d. So that if n here is 5, then we are going to get here to be u5, then a plus, then we are going to get n minus 1. Note that I said here the n here is 5, then we are going to get 5 minus 1, that will be 4. So we get here 4d. We get 4d here, which is a plus 4d. If n is 50, then we are going to get u50, and that is equal to a plus 50 minus 1 is 49, so 49d. So we can use this formula to find any term at all that we want to find. We can use the formula here to find any term at all that we want to find, we are interested in. So maybe we can take one example. After that, then we call it a day for this particular lesson. So we have this question to solve, which is the linear sequence is given by 1, 3, 5, 7, 9. Then we have find the 20th term. So the first term is 1, the second term is 3, the third term is 5, then we have 7, 9, and the sequence continues. So the 20th term is simply the number at the 20th position. 9 is at the 5th position. So if we continue on the 20th term, is the value that is at the 20th position. That's what we call the 20th term. Any term at all that you want to find, as we just found out, is given by un equal to a plus n minus 1d, a plus n minus 1d, where a is the first term, and then d is the common difference. N is the value or the term that we want to find. In this case, we are finding 20th term, so n is 20. So what we are getting here is we are writing un is now u20 is equal to first term. Our first term is 1 here, so that will be 1. Then plus n minus 1 is 20 minus 1, that will be 19. So we have 19. Then d is the common difference, which can be obtained by second term minus first term, or third term minus second term, or fourth term minus third term, or fifth term minus fourth term. Any of them you get 2. So the common difference is 2. And then here we are getting 2 times 19 is 38. Then we have plus 1, and that is equal to 39. So the number at the term at the 20th position is 39. And if you want, you can continue on the sequence and see and verify for yourself, and you find out that if you start counting from the first term 1, 2, 3, 4, by the time that you get to 20th, then the value there is going to be 39. So we have that. We call it a day. And if this video was helpful to you, please consider subscribing to the channel. By doing so, you will encourage me to do more, and it will also help our channel to grow. Thanks, and see you again.